Our next speaker is Alexander Dzionara, data scientist at, oh, sorry.
Oh, that's perfect.
Did I say it right?
Yes.
Okay.
Alex would have sufficed.
Oh, okay, I see. He's a data scientist at Bergfreunde. Alex will discuss the technical hurdles and solutions in implementing causal modeling at Bergfreunde. Also remember to head to slido.com to ask your questions. The event ID is on the slide. And welcome, Alex.
Thank you. Hi and welcome everybody. Also from my side, I'm very glad to be here. I think some of you might have heard Chris's talk earlier this morning, who talked a bit more about the business side of this project. I will talk more on some of the practical lessons from the data science perspective on how we implemented this project, and basically try to give you some key takeaways along the journey if you want to do something similar, some of the things we learned. As Chris mentioned, we call this project Decoding eCommerce because essentially we are trying to build structural causal models, or one structural causal model to solve a specific use case, namely business steering. And for those of you who were not there, who is our company, or who are we? We are an online e-commerce retailer specializing in the outdoor space, so we sell outdoor apparel and outdoor gear. We are active throughout Europe, and basically, again, we have these very two basic operational levers, namely marketing strategy and pricing strategy, that we try to balance on a weekly strategic basis to optimally steer our business. And the business question that this project and this use case is trying to tackle is basically, well, the business came to us and said, well, if we change our weekly marketing or pricing targets that we set on an organizational level each week to some specific value, to some specific strategy, how does that affect our final outcome, so our demand sales, so how much product we sell on to the demand that exists in the market. And from that, I think Chris mentioned it this morning, basically, they ask this question, which is a very causal question, because we know that if we change our targets internally and our business then in the operational processes acts according to these targets, that really has a huge impact on our operating margin and our profit in the end. So this is a super interesting question and a very important question for our business. The challenge basically that we are facing to answer this use case is, how can the business understand the causal impact of these operational decisions on the business performance? And this is again, I want to really reiterate this is a causal question, right? We're not just interested in making a forecast of our demand sales. We're actually interested in, if we change something strategically, how does that affect our final outcome? So what have we done in this project? Well, as Chris mentioned, we basically try to identify the causal pathways, try to set up a structural causal model that help us understand the pathways from business decisions to business outcomes. And then secondly, we obviously want to model and quantify those relationships to get some estimates, and then sort of run in the next step optimization questions, and also to be able to implement scenarios and ask interventional questions. Generally, I would say we had two goals. The first one was to help the business stakeholders understand the impact of their operational decisions. And the second one, and this is the one which really you've seen, if you've seen Chris' talk, is build a tool where the business user in their weekly operations meetings can say, hey, what happens if I run an intervention? I want to set this specific goal. I want to set this specific goal. These are the numbers we're expecting for next week. These are the targets that we want to hit. And what is the causal impact of that throughout some of the key KPIs that we observe in the business and our final KPI, the demand sales that we make. A brief interlude. So what is this talk? It is very applied. I will not talk deeply about algorithms used or estimation techniques. I will more sort of give you a more process-oriented talk and expose some of the challenges that we have faced, sketch some of the solutions that we have found, to just inspire you, hopefully, to give you some ideas on how, if you want to do something similar, you might approach some of these targets or questions. Also, as Chris mentioned, we still have some open things. We are still working on this model. We are further trying to improve the model, and there are some things that we want to improve on as well. So the first step, if you think about the pipeline from basically this business question onto the final product, namely the tool that you see when the business user sits in this meeting and sets their specific targets, is the first step is building a DAG, right? So building the direct acyclic graph that represents the information, that represents the causal flow throughout these different variables that you're interested in. And from a data science perspective, this is a very challenging task and something that is often looked over when we read about specific use cases, namely how do we actually get from domain knowledge to a DAG, right? If we just read documentations, we often have these ideal typical settings where the data either stems from a data generating process that we have implemented ourselves to sort of model stuff and learn about the tools. But as we all know, as data scientists, the real world often is very messy, and domain knowledge often is very obscure, is not really easily captured in the business, or sometimes doesn't exist, or sometimes it's just in very different places. So what we have basically done, and I think this is something that I really want to drive home, if you want to build a structural causal model, then I think you need to start from the domain knowledge. And often as a data scientist, this is not your domain of expertise, right? You are not an expert in, let's say, business steering. You're not an expert in pricing. You're not an expert in demands, right? Whatever marketing models. But you probably have someone in your business who is. And sometimes you sit then there in these meetings where you try to understand the process that you're trying to model, try to build a DAG, and you're just sitting there basically like, what the hell is going on? What am I even listening to here? I don't understand anything. Now I'm discussing about the 5th KPI that basically just means the same thing. And I want to tell you, these are the important meetings. Even though sometimes you really feel like your head is going to explode, everything you hear in these meetings and the domain knowledge really is the foundation of the DAG. And it basically encapsulates all the key critical assumptions that you build your structural causal model on. And if you don't follow through with these assumptions, don't listen to the process, then maybe if you have the wrong assumptions in your DAG, what model are you actually building, right? Is it a useful model? Is it actually a causal model? Or are you just fitting to some other stuff? So for me, and for us, this was a very long process. It was a very iterative process where we listened to the domain experts, built the graph, tested the assumptions, so ran some conditional independence tests, did some EDA, did some visualizations for the business key stakeholders, and then reiterated. And this is a process that takes time. So don't expect fast results. Sometimes you can get them if the process is very small and you're an expert in the process. Otherwise, it might take a while. Another thing that we found super useful was after we had built our initial graph based on domain knowledge, we ran additional causal discovery. And for us, the perspective on causal discovery in that setting was causal discovery is super helpful to generate hypotheses about the underlying graph. It does not tell you necessarily the truth, right? It suggests something. It suggests adding an edge. It suggests dropping an edge. It suggests there might be some unobserved confounders in there. There might be some missing connections. But it never tells you anything about the real world. It suggests you a hypothesis. And I think this is where the science part in data science comes in, right? If the model suggests something, if the algorithm suggests something, you are the scientist that needs to take that as a hypothesis, question the assumptions, and then either accept it or talk to the business and say, hey, what do you think about this? So again, for us, the key takeaway for building these structural causal models is that domain knowledge really is pivotal because this encapsulates all the assumptions that you really need to make about your model. Secondly, and this is something that we have done as well, is we ran multiple causal discovery algorithms. We compared them. All of them might generate slightly different outputs. In the slide up, I said we ran multiple oracles on these discovery algorithms and compare them, right? Take the input as hypotheses, go back and iterate. And this really, again, is something that is not really talked a lot about, but I think this is something that you really should be aware of. And this is something that people should know. Quick shout out to this FCI tiers algorithm. If you don't know the paper, it's an amazing algorithm for causal discovery because it allows you to structure knowledge into different tiers, and this allows you to integrate domain knowledge into the causal discovery algorithm. All right. Then we come to the next step. And the next step obviously then is model building and estimation. And here, now I want to talk about two specific points that we faced. And the first one is how do we deal with time, right? Chris talked about the fact that we have time series data, right? The business makes decision on day T0, and over the next 6 days, these effects materialize throughout the decisions of the company. We basically embraced non-stationarity. We said we can't get rid of it, right? It's there, it exists. This is the data that we have. This is what we're trying to model. But still, we didn't want to run like a full time series causal graph, but we took out some of the components of a full time series model where we said, okay, first of all, our business, we know, works on these weekly periods. So we use 7-day rolling windows to actually both train, but then also because this is the period of time that we're actually interested in our final application of the model. Another point that we really want to make is that we use 7-day lags to address some of the temporal spillover effects. What do we mean by that? If you listen to Chris's talk, he basically said, if we make a decision on our marketing strategy, then this translates operationally into some changes into our marketing department, and that translates into changes on the Google bidding algorithm, right? And the Google bidding algorithm is not our best friend, so it does not necessarily work in the second that we tell it to change something. It needs to learn and it needs to adapt. So we necessarily, if you change something in 1 week, this will have spillover effects, temporal causal spillover effects into the next week. And we need to address that. Right, so think about these temporal spillovers, maybe build in some lag variables into these structural causal models to address these specific questions. Furthermore, we use some lag variables to proxy for certain market conditions where we knew that we might not have actual data on some of the underlying causal mechanisms, but we could generate some proxies by using some lag variables. Finally, Chris talked a lot about the weather. We know in our data we are very weather dependent. Weather is very seasonal, right? So again, we embrace non-stationarity and say, okay, now we use exogenous variables that we know capture some of that seasonality, capture some of the time trends, and try to bring them into the model that to actually sort of deal with that. A final point, how we deal with time, and I think this is something that I also want to mention, we retrain and validate our model weekly. And why is this important? Well, I think this is important because obviously there might be some data drift in how the underlying structural parameters are estimated and actually also exist in the real world, right? It might be that sometimes causality slightly changes over time in the underlying data generating process, and thus it makes sense when you re-estimate the model to also take a look into, okay, what are the estimates, how are the estimates changing of these different parameters, and what are the model test statistics, how do they evolve over time? Because if you don't retrain the model, then you will have data drift, and then you might run into issues where the causal mechanisms that you're trying to model are not the same 1 year in the future. Another suggestion I want to make, and we really talked a lot about this as well, when we talk about these structural causal models, you have to make functional form assumptions about both edge activation and aggregation functions. So basically the functional form of the condition, the dependence between x and y, but also on how different nodes then flow into one specific target. And here we want to really encourage you to also think about the data generating process. Not just let the data speak, but also think about, okay, if the relationship between x and y from the business, from the domain knowledge, from the domain experts, we know there are diminishing returns, right? Then maybe it makes sense to sort of restrict the functional form to that setting. Why is that important? Well, it is important because if you think about, let's say, the distribution of the data on the specific node that you're trying to model into a target, if you don't have if the density is not uniform, right, but you have tails, then obviously in the tails towards the limits of the range, you will not have a lot of data. And if you implement a, let's say, linear functional form, then that might fit well given your data. But actually, that is only true because you have very limited data in the tails and you extrapolate via the functional form assumption from the structural causal model. So it also makes sense to keep that in mind when building the structural causal model. Again, go back to the domain experts and think about, okay, what are the assumptions, the underlying assumptions about the data generating process that I'm trying to bake into that model. So the key takeaways for us are basically embrace non-stationarity if it exists, deal with it in any way, shape and form you can. It might not be perfect, but at least don't ignore it. And again, we are very open to discussing that there are still some problems, and we still want to see whether there's some more. Finally, do not overchase predictive accuracy and rather take into account the domain expertise. All right, one final thing I want to briefly mention, and this is about interventions and nowcasting. We have talked about our structural causal model, but now the business came to us and said, hey, we have this one target, but we have a second target that we're interested in. What do we do now? We don't necessarily want to build a full structural causal model for these two new KPIs that the business now wants to bring into the structural causal model because they're interested in this new outcome. What have we done? Well, we decided to build two nowcasting models that we train on the same data that we use to train the structural causal model using the machine learning technique of choice that you want. But then, actually, when we apply that model in production, we can use the post-intervention outcomes of the structural causal model, pipe that into the machine learning algorithm to then get somewhat predicted outcomes of the target that we're interested in without having to build a full structural causal model for that specific target. Why is that important? Sometimes it's just not feasible, or you don't want to necessarily build this full structural causal model for some target. It might not be feasible, you might not want to do it, it might expand the scope of the project to some ginormous amount, but you still want to give the business user some insight. And then we really found this combination of machine learning prediction methods as a setup as a nowcasting model with the structural causal model to be super informative. I think the important part here is make it transparent to the business that this specific part might not necessarily be fully causal, right? So sort of make it sure that the business understands we have this one target and the additional supplementary targets that we're adding, the figures might be quite accurate, but they are based on a prediction and not on causality. And this is something that I think is the bit of the, you might not want to do it, but you probably can do it, hang up here, because getting that message across to business stakeholders sometimes can be very tricky. But again, it is very, very helpful if you need to do that. And we found it quite accurate, actually. I think you have seen this slide with Chris as well. Basically, then we want to productionize this tool, right, where we have a tool where the business users in their weekly operations meetings can set their expectations, can set their operational decisions, and that allows us run their interventions to then get a demand sales forecast or a nowcast or whatever for the next week from the structural causal model, and we can investigate along the different causal paths how does that affect certain downstream KPIs within the causal path, which is super helpful. So as a final summary, I think what have we learned? Well, we have learned that causal modeling techniques, specifically structural causal models, can integrate domain and process expertise with robust data modeling. And this is something that is super cool if you want to solve such a use case. We have also found that this nowcasting method really works very well as a supplementary add-on, but again, messaging towards the business is key here to keep expectations in check and not confuse the two. I think I hammered a lot on the sessions with the domain experts, but I think for the causal interpretations of the model that you're building, specifically if you're building a structural causal model, the assumptions in the causal graph are really pivotal. So this encapsulates the entire assumptions. So really spend time on building the DAG. Another method I want to shout out, just briefly, if you don't know about it, is intrinsic causal contributions, which is a very nice paper by Jansik and co-authors, which basically shows you how to specify the contribution of a specific node throughout the entire graph on the target. And this is super cool, and this helps you to visualize, specifically if you're looking at time series data, how the contribution of different variables changes over time towards your target, which can be also super informative. My final takeaway from going through that project is basically saying that if you are doing traditional machine learning data science projects, then for me, feature and model selection is often a data problem, right? So you're trying to find the best algorithm, you're trying to find the best features to explain your data, to give you the most accurate precision without obviously overfitting. But in causal machine learning, building a structural causal model is a problem that relates to the data generating process, right? So you should care much more about the underlying methods. You need to talk to the domain experts. You really need to understand the data generative process. So I think for me, this is the key distinction between the two methods and really something that we need to talk more about if we want to solve these kind of questions. Thanks.
Speaking of questions, we have some.
Oh, amazing.
I'm going to do the top two because we are running out of time. But the first one is a question. Can you elaborate a bit more how you deal with time? do you explicitly model the time, or do you simplify it somehow in your model?
So we do not explicitly model the time per se, so we don't have a time variable in there. We sort of try to attack the time component of different variables via lags or via seasonality adjustments. We do some, I think we tried some feature transformations as well, according to the time, some detrending. But I think we basically just embrace that time is a problem, try some different methods. And I think some of them I mentioned. But yeah, it's an issue.
Second question. Are you essentially doing transfer learning with nowcasting?
Are we doing transfer learning with nowcasting? Probably. Tough question. I'm not sure whether I would necessarily agree. But I need to think more about that. I don't have a definite answer on whether I would say we do that.
No worries. We'll do a final question then. What was the causal discovery method that you recommended?
Oh yeah, it's called FCI tiers, and it has it's a specific implementation of FCI tiers that the causaLens team has built into their platform. And it works quite well. They have a visual representation. I think you saw it. If you saw the very first talk, the intro, I think the LLM basically gave a suggestion where you saw some tiered nodes. And this is basically sort of part of the implementation of how causaLens implemented this algorithm in their platform. And it's incredibly helpful if you're trying to sort through different hypotheses on nodes.
Thank you very much, Alex.